Hello, stat students. Today we are going to start chapter 4. Chapter 4 is called Designing Studies. So we're going to take a look at how to design a study. Are studies appropriate? Were they carried out efficiently and in a correct manner? So that is what we're going to do in chapter 4. You can hardly go a day without hearing the results of a statistical study in the news. In this chapter, we will look at how to design and carry out a statistical study. There are two types of studies that we will look at. The first one is an observational study. This observes individuals and measures variables of interest, but it does not attempt to influence the response. Measuring occurs from watching or surveying, so asking questions, getting the answers that way, so it's subjective. Experiment, on the other hand, deliberately imposes some sort of treatment on individuals to measure their responses. The goal of many statistical studies is to show that changes in one variable cause changes in another variable. Remember, though, from last chapter, I'd mentioned causation is different from association. In association, you can show that two variables have some sort of relationship, a linear relationship, so be it, but that does not mean that one causes the other. All right, the first step in any statistical study is to identify your target population. So, the population in a statistical study is the entire group of individuals about which we want information on. So, for example, do we want to know information about all high school males or all high school males in the US or all high school males in the US that play sports? So, you have to be really specific about who your target population is. If you are going to include the entire population in your observational study, you would perform what is known as a census. And if your parents have mentioned it, you've gotten stuff in the mail for the 2020 census. I already have. I've already filled it out. But that's to get the entire population, everyone in the survey. But a census is often expensive and that's why it's only done every 10 years because you have to get everyone, so it's hard to reach everyone. So many times it is too difficult, too expensive, and too time consuming to include the entire population in your study. Therefore, we take only a sample, which is a part of the population from which we actually collect information. We then use that information that we collected from the sample to basically generalize or infer to the population. So we want to draw conclusions about the entire population. There are specific procedures for gathering and analyzing data that are rigorously applied as a method for arriving at results considered representative of the population. And we will do all that stuff later in semester 2. In this chapter, we're just focused on um, the types of sampling done to get the right sample, and then how we go about carrying the experiment or study. Okay. So, there are several types of sampling methods for a statistical study. The first one is a voluntary response sample, and this is a type of sample where individuals get to choose themselves. So, it consists of people who choose themselves by responding to a general appeal. And oftentimes they're paid to do it, not necessarily, but if you're looking at current situations, um, there's so many different companies trying to come up with a COVID vaccine. So you have volunteers that want to participate in a study, and they may get paid, they may not, and so on. So that is an example of a voluntary response sample where they choose themselves. The next one, oh, and this is, and as I just mentioned, a lot of time you see this in experiments, but that doesn't mean that it's the best type of sample you can get because that particular one, you get your really passionate people about certain things, and then you might not get anyone, others that don't want to participate because it takes too long or it's hard to do or whatever reason. So you just have extremes there. Okay, the next one is a convenience sample. This is a type of sample where individuals are chosen who are convenient to get results from. So if we were in school and we were doing a project of some sort and um, you just want to get your friends to answer your questions, or you're going to go to your third period class and get all your responses. So you're only sampling from your friends, you're only sampling from your high school, so on. You're getting easy to reach individuals. So again, this one is not a very good method because it's not truly random. Next one is systematic sampling. This consists of randomly choosing a starting value, and let's call that starting value H, and then randomly choosing an interval, K, choose the eighth person to start with, and then choose every kth person from there to be part of the sample. So, for instance, if you are doing whatever sample you're trying to get, you see 100 people outside the stadium, and you're going to start with that first person who is there, and then you're going to collect information from every seventh person. And then, so every seventh person you're going to get information from. That would be an example of systematic sampling. Now, this one, some people like it and it's used often, but it's doesn't always get everyone in the sample because there are some people that are never going to be able to be chosen. So, not the most random, but still better than the other two. Okay, for our intents and purposes, our best type of sampling is a simple random sample. That's the one that's truly most random. So it consists of n individuals. Now, n is your sample size. So it consists of n individuals from the population chosen in such a way that every set of n individuals has an equal chance to be the actual sample chosen. And these are just a few methods. And this is the method I use in the classroom when we're in the class. And if I want to partner up people, if we're doing an activity, or if I want to give a partner quiz, which I've done, um, I put all the names in a hat. I make sure that all the pieces are the same size so everyone has an equal chance of being chosen. And then I randomly pick from that hat and I choose my sample. So that's a really convenient, very simple, basic way to do a simple random sample. Another one is the random number method. So each individual is assigned a random number. So for instance, you guys, there's 25 of you. So I can use a calculator and I would use 1 through 25 as my numbers. And if I wanted to do um, partners, I would pick 2 numbers at a time, and I would pick the ones my calculator does the random integer no repeat, so I would choose that, but not every calculator does this. So if you were using, a calculator, and we'll use that more, next lesson, you go to Math, and then you go scroll over to Probability, and then you choose number 5, which is random. Well, this on my calculator is number 5, but whatever it is on yours. It's random integer, and you select that. Like I said, I use the random integer no repeat because if I'm doing like 1 through 300 and I want 20 numbers, I don't want them to repeat. Then I just have to skip through them. For this first section, we're going to use Table D, which is in your book, but you don't have to have the book because I'll give you a portion of Table D. Now, will you have Table D on your reference, your formula sheets? You won't, but you will always be given a portion if you're going to be asked a question about choosing something that's random. So we're going to do Table D for this particular notes day, and then the next lesson we're going to do calculator. So each individual is assigned a random number. Each number must have the same number of digits, and I'll mention that when we're doing our example problem on the next page. Now, if you're using a calculator, you can just do 1 through 20, like the number 1 dash 20. And so if you notice, 1 only has one digit, 20 has two digits. The calculator doesn't care that you use 3 digits, 5 digits, so on, but a random um, number generator, as far as using a table goes, you do have to use the exact same number of digits. Okay, what can go wrong with sampling? So, this is known as sampling bias. So, the design of a statistical study shows bias if it systematically favors certain outcomes. It leads to systematic errors, which will then overestimate or underestimate a result. And we'll talk more about what can go wrong in sampling later in this section. Sampling that leads to bias and systemic errors are samples that are not truly representative of the population. And like I mentioned on the previous page, those types of sampling methods are voluntary response samples and convenience samples. Systematic is not bad because there is some sort of randomness in it, but it's not the best one to use. Note, most studies will require you to describe your sampling method to ensure that you have eliminated, well, eliminated is not the best word, I'll put it here, because you don't really truly eliminate all bias, but your goal is to reduce it. So this is a better word here. Be prepared to write out how you assign the individuals numbers. So did you use the hat method? Did you use a random number generator and a calculator? Did you use table D? How you assigned the individual's numbers and how you selected your sample. You always get a question like this on the AP exam. So the AP exam will usually give you a table of random digits and have you describe your method for a free response problem. Now, if you don't correctly describe it or fail to leave it out, then you're going to be in big trouble, right? The correct ways to sample a population, so random sampling. Using these methods leaves the choice of who participates to chance, thereby eliminating the chance of personal bias from those either participating in the study or those that are conducting the study. A systematic sample, which I mentioned on the previous page, is only a random sample if the values chosen, so the starting value and the interval, are randomly chosen. There is still some debate about if it is truly random because once the starting value is chosen, some people have no chance of being selected. And that's not having equal chance of being selected. It can also become problematic if the interval picks up on any unknown or underlying pattern. So, like the first 100 people, I mean, they might have a certain thing in common. So if that's the underlying pattern, then you're not really inferring about the whole population. So far, the only true random sampling technique is that simple random sample known in our class as the SRS. All right, and we will end this section with an example. So this one is called Mall Hours. The management company of a local mall plans to survey a random sample of 8 stores to determine the hours they would like to stay open during the holiday season. There are 20 stores in the mall. The stores are listed below. So we can do the first few questions without having to number anything. So, what is the population? Remember, the population is the entire group. So, in this case, the population is all of the stores in the malls. There happen to be 20 of them. So, sometimes they'll ask you for a value on a multiple choice question. So, in this case, you would say, um, 20 stores in the mall. Okay, what is the sample? Our sample will be 8 randomly chosen stores. So always make sure you write down that they have been randomly chosen. What are we measuring? We are going to measure to see um, or determine the hours to stay open during the holidays. Definitely take notes in this chapter as there are just so many different things that are going on. Wait till we get into experiments and you have to learn the different types of experiments. So you always want to take notes so you have those handy with you. All right, and the next thing we're going to do is describe. So this is really important. It's asking us to go about how we're going to select our sample using the table of random digits below. So remember, there are 20 stores. So this is a 2-digit number. And so we're going the old school method. We're not going to use a calculator for this. So with this old school method, you are going to use 2 digits to number these 20 stores. So right here to the side, just go ahead and number one, 01, all the way through 020, or I'm sorry, to 20. Students forget to do this and then they do it wrong. They haven't done it correctly if you're not going to use 2 digits. So the largest number determines how many digits you're going to use. So if there's 100 numbers, you are going to start numbering 001 to 100. There we go. So that's the first thing we're going to do. So let's describe this information somewhere. And I am going to describe it. I'm going to write small here because we have to describe our method. So I'll put over here, I'll start right here. Okay, so since there are 20 stores, and you have to describe it, you don't just number them, you have to tell in words what you are doing. Since there are 20 stores, I label each store with a 2-digit number. All right. And now I'll show you how to use the random digit table. I went to the table and marked off 2-digit numbers. Okay, I'm gonna stop right there. We're gonna continue writing more information, but now I'm gonna go to the table and I'm gonna mark off starting with, and you can, it depends, you can start at line 102, 103. I always start the first one so you know you're gonna have enough. Because remember, we have to come up with 8 randomly chosen stores. So I'm gonna go ahead and mark them off. So one, so every 2 digits. What I'm gonna do is I'm gonna start circling anything that is from 0, 1 to 0 or to 20. 1. So that's 2 stores so far. Here's one 0, 0, but you have to skip 0, 0. Oops, I kind of gave something away. Here's another one. Uh, I feel like I have enough, so I might stop. All right, so let's write down some of these numbers. So we have 19, so store number 19 happens to be Vitamin World. Um, and then the next one was I circled 5, which is Carter's for Kids. And then I circled 13. Then I circled, or did I circle anything? I did, 19. And then I circled 17. 9. I have 0, 0. 13. I have, where am I? 7. I have 2. And I have 1. I have more than 8 here. But we can't select the same store twice. So this would be an example of a repeat. So you cross it out. You have to mention why you crossed out a repeat and so on. So we'll mention that in our table. This is also a repeat. And notice there is no store 0, 0. So cross that out. So I think that gives us 1, 2, 3, 4, 5, 6, 7, 8. So 8 stores. So we can go ahead and continue writing right over here what we did. So we marked off 2-digit numbers, but, or in addition, we skipped. So skipping repeats and skipping zero, 0, and the numbers 21 through 99. So that is really important that you write down exactly what you did so someone can follow the method of your choosing of a sample. So what happens to repeated labels? We mentioned that. Always state what you're going to do if a label is repeated. Usually we ignore if an individual is repeated. And so at the end, let's answer our questions. It doesn't really ask. Oh, yeah, it does. So Oh, no, it doesn't. Okay, part C just asks us to describe, but we're gonna come up with a conclusion. So in our conclusion, we can say the stores selected are, and you can go ahead and circle them or just write them down here, but are Aeropostale, All American Burger, Carter's for Kids, Famous Footwear, GameStop, Mrs. Fields, Payless Shoes, and Vitamin World. And that is it for our notes today. Have a great day, stat students.